Okay, we have a square, and it's growing. Somehow the square is growing. All right?
I know the sides are 8.
Very good. The sides are also growing, so we're going to give them variables. Okay? I'm going to call this side x, and because it's a square, I'm going to call that side x. You can use any letter you want. Your initials, go for it. Okay? So, here's, again, with a question like this, when you see that how fast, they're asking for a rate of change. Figure out the rate of change of what? How fast is the perimeter changing? So we're going to write that as dp dt. That's what we want. We want to know how fast the perimeter is changing. And they happen to tell us that the area is changing at 40 square centimeters per minute. So this is another thing you got to keep in mind, that the dimensions on your units have to match what they measure. All right? So area has to be measured in square centimeters or square inches. But perimeter is just a length. So that's going to be measured in like inches or centimeters or something, or centimeters in this case, yeah. Okay? But we want dp dt, and they tell me that dA dt is 40 square centimeters per minute. So all we need is an equation that links perimeter to area. And once we have that, we can derive it, because we'll get a dA dt and a dP dt. Since we don't have that like right off the bat, right? You guys don't know perimeter area relationship. You know perimeter with the side length. So let's start with that. The perimeter is 4x. Okay? So we can go 2 routes with this. I'm only going to do one. But we could derive this the way it is. We're going to get dP dt. We're going to get dx dt, right? We want dP dt, so that means we got to be able to find dx dt somewhere. Okay? But I know dA dt. So if I can link x and a together, then I can find dx dt by using dA dt. Does that make sense? Okay. Let's just do it this way. Look. Let's say we just derive it the way it is, okay? We get dP dt equals 4 dx dt. Now we're looking for dP dt. The problem is we don't know dx dt. We know dA dt. So now my problem becomes, let's not look for dP dt anymore. Let's look for dx dt. And because I know how fast the area is changing, I'm going to use the area equation, which is that the area is x squared. When I derive that, I'm going to dA dt and dx dt, and that'll allow me to find dx dt. Okay? A lot of dt's being thrown around here. But when we derive this, you get dA dt equals 2x dx dt. Okay? We know dA dt is 40. Boom. We know that this is 2, and we knew the diagonal was 8 root 2, it says in the problem, and we just use this magic rule so often here.
It's 8.
It's got to be 8. X has to be 8 because the diagonal is 8 root 2. So this is 8.
And that's 4 over 10. And that's 2 over 5.
It's 5 halves.
Oh, yeah.
Yeah, right? Because look, check this out. Instead of doing all that division, look, you guys, you're not watching me here. Just divide by 8. Boom, boom. That becomes a 5. 5 halves. Okay?
See, I would never think that.
So, yeah, again, like that's the big complaint I get every year from kids. We got such big numbers. Well, divide them out first. Don't put them all together. So we divide out. We get 5 halves. And once we know that, now I can plug this in here, and it turns out it is 10. It's 4 times 5 halves, and that is 10. And it's centimeters per minute, because perimeter is measured in centimeters. Okay? So I hear that all the time. When you do it, I get it. It's so easy. Okay. Hold on. Listen. I'm going to go back and show you one other way we could have done this, because sometimes you think this way, okay? So look, let's just real quick. Let's go back to our perimeter equation was 4x, right? Okay. Something you can do instead of deriving this right off the bat is, because we know dA dt, I might want to get rid of x in this equation and get a in there somehow. Does that make sense? So when I derive it, I get a dA dt. I want to sub out x and plug in a. So we're going to do a substitution, but we can't just take out x and put in a. We got to make it equal, which means I need another equation so I know what they're equal to. And so we're still going to use this equation, the area equals x squared, but I'm just going to solve for x. So x is the square root of a, and then if we rewrite this like this, now when I derive it, I get a dA dt right in that equation. and I can just plug in and solve that out. Okay, you're going to get the same thing, because look, just again, real quick. When you drive both sides of this, you get dB dt equals 4 over 2 root a dA dt. Okay? I think this makes more sense initially, because that's what I always tell you. Get an equation that links the rate you know to the rate you want to know. Or, we don't know what a is, but we know that the diagonal is 8 root 2, so the side length has to be 8, so the area has to be 64. And you get dP dt equals 4 over 2 times 8 is 16, and dA dt is 40. So a fourth of 40 is, oh my goodness, 10. And that would still be centimeters.
So we didn't even use the Pythagorean theorem.
This isn't on the Pythagorean theorem, when is it?
Yes, it is.
Oh,
You lied to us.
whatever, well, eh.